Okay, let's look at the section 5.1. This section talks about a counterexample. All right, so we are trying to use a counterexample to disprove a universal statement like this. Right, for all x in S, P of x. All right, but since we're used to proving things instead of disproving things, maybe we should think in terms of proving something, right? So this is equivalent to, right? So if you want to disprove something, we should prove its negation. So we can just go ahead and try to prove the negation of this universal statement. So for all x in S and P of x, right? So we just learned how to negate the universal statement. So this is logically equivalent to, right? There exists some element x in S such that not P of x, right? All right, so you can see that the negation of for all statement is really there exists statement. So all you really need to do is to come up with one example such that not P of x is true, right? Which is called counterexample, right? So let's look at an example. All right, so we need to disprove for all odd positive integer n 3 divides n squared minus 1. All right, so let's try to disprove that. All right, so first, all right, so let's try to come up with a counterexample. Let's say odd positive integer, so let's try 1. 1 squared minus 1 is 0. 0 is divisible by 3. That doesn't work. So next odd positive integer would be 3. 3 squared minus 1. So 3 squared is 9, minus 1 would be 8. 8 is not divisible by 3. So that would make a counterexample, right? So we say, right, let, maybe I should, I'm gonna say try. Let's try this example, right? So that would be n equals 3, right? So this is an odd integer, so that's good, and also definitely positive, and it's an integer, right? So it satisfies that. So this is our counterexample. Example. All right. Right, so we have to verify that this is really the case. So next line is going to be, so we have to look at the n squared minus 1. So consider n squared minus 1, which is, of course, just substitution. 3 squared minus 1, which is going to be 9 minus 1, 8. Right? We want to see if this is divisible by 3. So 8 is same thing as 3 times 2. Then you have a remainder 2. Right? Right, so this is just coming from the fact that n equals 3. So it's using fact and a little bit of algebra to get that. Right? But you can see that the n squared minus 1 is 3 times 2. Then you have a remainder 2. So it's not divisible by 3. So you have 3, right? So we know that 3 does not divide 3 squared minus 1, right? So that just comes from line number 2, right? Then we established that this is a counterexample. So we already found, right? So therefore, there exists some odd positive integer n, namely in this case 3, such that 3 does not divide n squared minus 1. Right? So this comes from line number 3. Right? That will verify that n equals 3 is a counterexample, which disproves this universal statement. Right? That's it. I hope that this was clear.